All right, so we have done one-step, two-step, multi-step equations with distribution. One thing we haven't done is what they show right here. What you'll notice here is that all of a sudden I now have variables on both sides of this equation, all right? And so whereas we just had to worry about getting stuff away from our x, now we have x's on both sides. And so when you have x's on both sides, you're going to have to congregate them. You're going to have to put all of your stuff with x's on one side and all of your things that don't have x's on the other. And then you'll be able to multiply or divide and just solve. All right? And I will tell you this, it doesn't matter which way you move it. Some people will always move their variable to the left and their numbers to the right because they want it the same every time. I often do it so that I don't have to worry about negatives. So maybe I'll move my smaller x over to the bigger x, and then I don't have to worry about dividing by a negative. But however you do it, as long as you do it, mathematically correct, you're going to get the same answer. It doesn't matter which way you move it. As long as all of your variables end up on one side, all of your numbers end up on the other. Okay? And so let's look at the first problem here. This is a rather simple one. We don't have any distribution, nothing like that, but we do have variables on both sides. And so the biggest mistake people make here is they move everything to one side. That's not what you want to do. So you're going to choose where am I going to move my variable and then make sure your numbers go to the other side. So in this case, I would actually move my variables over to the left-hand side. I would actually move all my variables over here, and then I would take all my numbers and make sure they were over on the right-hand side. So if I do this particular problem, 2x plus 5 equals x minus 2, to get my variable over, I do exactly the same as I did before, whatever the opposite is. Right now, you're always going to be adding and subtracting to move it across. When we just have variables and numbers left on each side, then you're going to divide. But right now, we're going to subtract. So to move this x over, it is a positive x. I'm going to subtract an x. So I'm going to move that over. On the right-hand side, a positive x and a negative x will cancel out. I just have this negative 2 here. On the left-hand side, I have 2x minus 1x. So I have just x, and I still have this plus 5 here. And then don't forget to bring down your equal sign in between them. Now that I've moved my variables over to the left-hand side, I need to move that number over to the other side. So now this 5 needs to go over to the other side. So I'm going to take the 5. It's a plus 5 right now. I'm going to subtract 5. All right. On the left-hand side, the positive 5 and negative 5 cancel. Bring down your equal sign. What is negative 2 minus 5? Negative 7. And that is your answer there. Negative 7. All right, negative 7. You can check it. So you can always check these. 2 instead of x, negative 7. Plus 5 equals negative 7. Minus 2. Order of operations. 2 and negative 7, negative 14 plus 5 equals negative 9. Yes, negative 9 equals negative 9. All right. So variables to one side, numbers to the other. You're just trying to get it by itself. So always do your distribution first. 3 times x is 3x. 3 times negative 4, that's negative 12. Put your equal sign, and then on the right, we're going to distribute a 4. 4 times x. And 4 times negative 6. Again, it doesn't matter which side you move it to. You can move it to the left, move it to the right. It doesn't matter. If you move your variables to the right, you'll get positive numbers. If you move it to the left, you'll get negatives, and divide, you'll still get a positive in your answer. But just pay attention to your positives and negatives as you do this. If I move it to the left, then I'm going to take this 4x and I'm going to subtract 4x from both sides. All right, on the right-hand side, the 4x's cancel. I have just this negative 24. Negative 24, bring down your equal. 3x minus 4x is negative x, negative 1x. And we still have this minus 12. All right, minus 12. I need to move the 12 over, so add 12 over. It's going to cancel on the left. I still have negative x here. Negative 24 plus 12 is negative 12. I am not finished. I still have a -1 in front of my x, okay? You're not solving for negative x, you're solving for x. So divide by -1, and x equals 12. Now, we could have moved my x's to the other side. So let's look at it if we do that. 3x minus 12 equals 4x minus 24. So now let's say I want to move my x's to the right side. Minus 3x. I'm going to move it over to the right. On the left-hand side, my 3x's will cancel. I will have just a -12. Bring down my equals. 4x minus 3x is x. I still have this minus 24. Now I want to move my numbers to the opposite side, so I'm going to move the 24 over. On the right-hand side, it cancels. I have an x equals -12, and 24 is 12. So whichever side you move it to, you will still get positive 12 as your answer. So as I look through this one, I don't have any distribution. So I'm just simplifying here, which means I combine my like terms. Do not do the opposite when you're just combining. I see it all the time. You're just combining. 5x and 3x is 8x minus 4. Now I can start moving my variables to one side, my numbers to the other, and then I can divide at this point. All right, and just leave it as a fraction. Make sure if you can simplify it that you simplify it. So if you can reduce it, but you can just leave it as a fraction or an improper fraction. All right, so for the first one, we have 7x minus 20 equals 2x plus 25. This one's pretty straightforward. We don't have to combine anything before we do it. The left side is as simple as it can be. The right side is as simple as that can be. So we can go ahead and start moving our variables and numbers over. So I would subtract your 2x from both sides. When you do that, on the right-hand side, it's going to cancel. And you just have your 25. On the left-hand side, 7 minus 2 is 5. X, you have minus 20 there. You're going to add your 20 over. The -20 and positive 20 will cancel. I just have 5x equals 45. And then my last step here, I can divide by 5, which gives me x equals 9. Second one, you have to distribute. So I'm going to distribute my 4. 4 times x. 4 times -9. On the right-hand side, I'm going to combine like terms. 3x and -8x give me what? -5x. All right, I can subtract my 4x over. I would actually do that. When you have a 4x by itself on one side, go to that side with your variables. If not, you're going to have a 0 and you're going to confuse yourself. All right, so 4x and -4x cancel. They get zeroed out. I have -36 equals -5 and -4 are -9x. Divide by -9, which is where we get our x equals 4. The last one's the most difficult, obviously, right? Lots of distribution going on here. So for this one, I'm going to distribute the 8. 8 times 2 is 16. 8 times 1, 8. Here, what am I distributing? Yeah, I'm distributing a -1. -1. So -1 times positive t, -1t. -1 times -9 is a positive 9. And on the right-hand side, I actually cannot simplify anything. Cannot simplify anything there. On the left-hand side, I can still simplify more, right? I've distributed, but I can actually combine like terms. So 16 and -1 give me 15. 8, 9, what does that give me? 17. Right. So far, so good. All right. Now I'm going to move my t's to one side. All right. So on the left-hand side, I have 15t and 8 plus my 17 equals negative 52. Then I'm going to move my numbers to the other side. These cancel. Remember a negative, when I subtract, I'm going to just add those, right? And then I will be able to divide by that 23. And it will divide evenly, which will give me negative 3. So when you're given one of these, you're not going to know that you have a special case until you're done solving. So we're going to distribute our 3. 3 times 4x. 3 times negative 5. And then don't forget you have this plus 2 here. On the right-hand side, distribute your 2. 2 and 6x. And then 2 and 3. We're going to do exactly like we would. Combine your like terms. Negative 15 and 2. Once I do that, I've simplified both sides as much as I can. And I'm going to move my numbers to one side and my variables to the other. What you'll notice here, however, is that when I move my variable, I get 12x minus 12x here. What does that give me? What's 12x minus 12x? 0. So I'm left with just negative 13. Bring down your equal sign. 12x minus 12x here. 0, and I have 6. When does negative 13 equal 6? Never. Negative 13 never equals 6. All right, so this is the first special case. You get rid of all your variables and you have some number equals another number, but it's not true. All right? When you get something that is not true, then you have no solution. And so on a quiz or test, this would actually be your answer. This would not be your answer. That's not a true statement. What would be your answer are the words no solution.
0.
Look at this one. We're going to solve it exactly the same way. We're going to distribute, now the 8 here, leave it alone. We are distributing a negative 1. So negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. Here we're distributing a negative 2. Negative 2 times x. Negative 2 times negative 6. And then we have this plus x. All right, combine your like terms. On the left-hand side, what are my like terms here? 8 and 4, so I have 12 minus x. On my right-hand side, what are my like terms? The x's, negative 2 and positive 1. Again, if I move my x's over here, on the right-hand side and on the left-hand side, my x's will cancel. Negative x and positive x. I'm left with a 12. Bring down my equals. Negative x and positive x cancel. I'm left with a 12. When does 12 equal 12? Always. This is a true statement. If you get a true statement when you cancel out all of your x's, then this is going to be all real numbers. You can put any number in this equation and it will be true. You can write all real numbers, or if you remember the symbol for all real numbers, you can put that too, as long as you put the symbol for it. All real numbers. Any number that you pick for x will work. 1, 2, 3, 4, negative 725. Plug it in, it's going to work. All real numbers. So if you get rid of all of your x's, there are two possibilities. You'll have a true statement, that's going to be all real numbers, or you will have a false statement, that's going to be no solution. All right, so if you ever have an equation and you have gotten rid of all your variables because you just subtracted and they zeroed out, then you're going to have one of two options as your answer, either no solution or all real numbers. All right, those are technically your special cases. The last example on the next page is not a special case, but it is something that people try to tell me no solution when they get it. And that's when you get 0 as an answer. So let's look at the last example. The last example. We're going to solve it exactly the same way. All right. We're going to distribute my 2. 2 times x. 2 times negative 3. and then plus 6. Then we have 3x plus 2. I am distributing a negative 1 here. Negative 1 times 2. Negative 1 times negative x. All right? Combine your like terms. On this side, my like terms are negative 6 and positive 6, so I just have 2x. Over here, I have 2 and negative 2. That is 0, so I have 3x plus 1x is 4x. All right? I need to get my numbers to one side and my variables to the other. So if I subtract my 2x over, what is 2x minus 2x? 0. 4x minus 2x is, I need to divide by 2, right? Divide by 2. What is 0 divided by 2? 0 equals x. That is an answer. That is not no solution. That is not all real number. It's x equals 0. The only number that's going to work in this problem is 0. If you plug a 0 in, you will get a true statement, okay? So if you get x equals 0, that is an answer. It's not a special case. It's not a no solution. It is x equals 0. 0 is a number, right? On the number line, we see that 0 is a number. And so a lot of times when I get students who get x equals 0, they're like, oh, I did something wrong. This must be no solution. That's different. No solutions when you get a false statement. 2 equals 3. All right, so this has a solution. It is 0.